Dear students, I welcome you for the today's lecture related to the heat, the different units, the concept of temperature that we are going to discuss today. So heat, the energy that flows into or out of a system because of difference in temperature between the thermodynamic system and its surrounding. That is also one definition, including the thermodynamic system. The thermodynamics and heat transfer, these are the two different subjects. What difference is there, that we will study in the next class. However, at this time, we will take into account the thermodynamic system and its surrounding. So, one is having the temperature difference between the two systems, then and only the heat that is going to flow. So, that is the energy. Heat is nothing but the energy that flows into or out of a system. Then it is defined by generally small q or capital Q. And when the heat is evolved by a system, that is the energy is lost from the system, it is taken as negative in case of your endothermic reaction. And when the heat that is absorbed by the system, the energy is added into the system. So Q is taken as positive, that happens in your endothermic reactions. Generally, the units of heat are your joules or calories. Yesterday we have seen the caloric, previously that caloric concept was there, and then the joule had worked on it to define, and on his name the unit of joule that is there. Heat energy is usually measured in either joules given by the unit J, and 1 calories, which is equal to 4.184 joules. So calories is one of the units, that is the amount of heat needed to rise 1 gram of water by 1 degree Celsius. In our thermodynamics, we talk related to the calorimeter. That is a device used to measure the heat given off during the chemical reaction. You must have done some of the experiments using the calorimeter to measure the heat of reaction or heat of solution. So device used to measure the heat given off during the chemical reaction means whatever the heat that will be given out or generated in a chemical reaction, or amount of the heat that will be absorbed by the system in the process of chemical reaction, that one can be able to measure using the calorimeter. So joules, that is also another unit, mass and type. Then the heat transfer involves a chemical reaction. Then Q, that is called the heat of reaction. Whenever there is a chemical reaction that is taking place, we call it the heat of reaction. And the heat energy or the enthalpy that is required to return a system to the given temperature at the completion of a reaction. So that is the Q, heat energy, which is equal to the enthalpy delta H. This is at a constant pressure. Then the heat of reaction can be specific to a reactions. Now, if the reaction that is taking place as a combustion reaction, then it is called the heat of combustion. The quantity of heat energy given off when a specified amount of substance burns in oxygen. Then the heat capacity and the specific heat. Heat capacity, that is the amount or the quantity of heat needed to raise the temperature of substance by 1 degree Celsius or 1 Kelvin. So that is the of a substance by 1 degree Celsius. That is the amount or the quantity of the heat needed to rise the temperature of a substance by 1 degree Celsius. And when the term specific heat is there, that is the quantity of heat required to raise the temperature of 1 gram of a substance. That is the difference. Here, the 1 gram, when we talk in terms of a 1 gram, that is mCp delta T. So that is the 1 gram of a substance by 1 degree Celsius. Specific heat, that is the ability of substance to absorb the heat energy. The different substances absorb the heat at different rates. That is important. The different substances absorb the heat at a different rate. The greater the mass of object, the more heat that is absorbed. So this is what we have seen yesterday also. That is the air of mass 1 kg when it is heated from 300 degrees Celsius, 300 Kelvin to 301 Kelvin, you require 0.718 of the kilojoules of the energy. However, when the same amount of the mass you are heating it from 1000 Kelvin to the 1001 Kelvin, you require 0.855 kilojoules. So it is the temperature is one of the factors, and the rate, that is also the different factor. Then at the same time, the another thing is that do the different materials need the same amount of energy to increase their temperature by the same amount? To increase the temperature of 1 kg of water by 1 degree Celsius, you require 4200 joules. And this, I suppose, everyone remembers that the 1 kg of water by 1 degree Celsius requires 4200 joules. And if it is a copper, then you require 390 joules. Then the water and copper requires the different amount of energy because they have the different values of the property called the specific heat capacity. How much amount of the heat that can be held by that substance when there is an increase of 1 degree Celsius. It is the amount of energy required to increase the temperature of 1 kg of a material by 1 degree Celsius. So the specific heat capacity for water is 4200 joules per kg degree Celsius, and for copper it is 390 joules per kg degree Celsius. Then the lower a material's specific heat, the more its temperature rise when energy that is added. Now here the water and the lead that is there, which will heat faster and has the lower specific heat. The Cp for water is 4200. However, the Cp for lead, that is less. So, which will heat faster? That is the lead will heat faster. That depends upon the Cp, because to increase the 1 degree Celsius, you require 4200 joules per degree Celsius of the amount of energy. However, for copper, it is 390 joules per kg, joules per degree Celsius. So the copper lead will heat at a faster rate as compared to the water. For copper, it is 460 joules per degree Celsius. So it is nothing but mass into specific heat into temperature change. Now this specific heat, it is the amount, this term is very much needed. It is also the sensible heat that is stored. So there are certain examples. One can, you have already done these examples in your previous classes. That is simply a revision. Now coming to the concept of temperature. Now what exactly the temperature is? We measure it with the help of any thermometer, or nowadays your contactless thermometers, that is your sensors, they are being used. So if sometimes gain a lot of heat energy, it becomes hot. Now when you say gaining a lot of heat energy, gaining a lot of energy, then and only the temperature rise that takes place. So temperature is measured of how hot or cold an object is and is compared with the reference point. This is important. It is compared with a reference point when we talk related to the hot and cold. Comparison is there. It is not the total amount of energy contained in an object, because we have already seen the specific heat values, they are different for different material. So the amount of energy available with each material is different. But temperature doesn't measure the amount of energy. It only measures the rise or change in temperature. It is not the total amount of energy contained in the object. So when we calculate the Q, which is equal to mCp delta T, Q is the amount of heat energy and m, that is the mass that contains, and you require the Cp value. So depending upon the Cp, specific heat values, and the change in temperature, the amount of heat associated with that substance is going to vary. So temperature is measured in degrees Celsius. The temperature can be measured by different, that is thermometers that include the liquid in the glass or digital thermometer that you know. So heat flows down the bar to the collision. Whenever the collision that takes place, the heat that is going to flow. Let us see this bar that is getting heated from one end, and slowly the temperature at the other end that will also increase. So the collision transfers the thermal energy from hot to the cold end. Collision of the molecules that transfers the heat from one end to the another end. Now the temperature is, what is the temperature? It is the average kinetic energy of particles in an object. Temperature is the average kinetic energy of the particles in an object. So how much is the kinetic energy? Because of increased supply of the heat, the kinetic energy of the molecules that increases, and as a result, the change in temperature that is noted. So temperature is nothing but the average kinetic energy of the particles in an object. So kinetic energy is the energy of motion, and temperature is the measure of average kinetic energy of an object. Thermometer, that is nothing but yes, we are having the three scales, that is the Celsius scales, measure the temperature. Then Kelvin scale, that is also there. So Kelvin scale, one has to write the K in the small. This is to be noted, Kelvin, Kelvin, and not the capital Kelvin. And when you write the Kelvin unit, it's the capital K, and it should not be degrees Kelvin. You have to remember that you will never write degrees Kelvin. We are writing degrees Celsius, we are writing degrees Fahrenheit. However, for Kelvin, it is only the capital K that is written. Because 273.15 plus degrees Celsius, which is equal to the Kelvin. So never write degree Kelvin. It is only the Kelvin that is to be written K. So the units for power is nothing but the watt emission black body. Generally, why do objects get hotter or colder? That is, temperature is measure of how hot an object is. So here in the figure you can see a lolly and tongue. The heat transfer as the tongue is hot. The heat from the tongue is transferred to the lolly and it gets melted. However, the reverse process that is getting happen, that is the heat which is getting absorbed into the lolly. So your tongue loses that heat. Tongue loses heat, and as a result you feel the cold to the tongue. So it is not the same as the heat energy, although the two quantities are related. For example, a beaker of water at 60 degrees Celsius is hotter than a bath of tank of water at 40 degrees Celsius. That means a beaker which is at 60 degrees Celsius and the tank which is at 40 degrees Celsius. But when you calculate the amount or the joules, then the amount of the energy associated with the tank is more as compared to that of beaker, because the mass factor that is also there. So heat and temperature are among the most misunderstood concepts. The temperature is a physical state based on the molecular activity of an object. If you cut an object into halves, each half will have the same temperature. The temperature will be the same, even though if you will cut any, but the amount of the heat associated, that will be half. Temperature will remain same, and the amount of heat associated, that will get half. J, that will be reduced. J will be 1 by 2. So heat is a transfer of energy which might change the state of a temperature. Heat can be transferred without a change in temperature during a phase change. Now here the phase change that is also required to be studied. One is your sensible heat, the specific heat that counts or related to the sensible heat, and latent heat that is associated with a phase change. Even though we supply the heat, we go on supplying the heat for the phase change, the rise in temperature is not observed. Even though we supply the continuous heat for a phase change process, there is no change in temperature that is observed. Now where this energy is going? This energy is going into the phase change, and this is also called as the potential energy. Water at 100 degrees Celsius and steam at 100 degrees Celsius. Which will have the higher energy? The steam will have the higher energy because there is a phase change, and in the process of phase change, the water has gained the phase change or the latent heat. So it becomes your potential energy. Temperature change is the kinetic energy. Temperature, when we note, it is nothing but the kinetic energy of the molecules. So we are understanding here today that is related to the sensible heat and the latent heat, and there is a temperature which is change in temperature which is associated with the kinetic energy of the molecule. However, the potential energy that is associated with the latent heat. So heat is transfer of energy which might change the state of a temperature. Heat can be transferred without a change in temperature during a phase change. So there is no such concept as the amount of heat in an object, or the heat is an energy transfer. So absolute zero, that we know the temperature in which all the molecular motion stops, 0 Kelvin. That is your absolute zero. Thermostat is a device that controls the temperature. The switch of thermostat is a bimetallic switch. The two different metals that are bound together, they expand at different rate when heated, used as a switch in thermostat. So internal energy, that is the energy within a substance. So heating and cooling, heat energy always moves from hot object to the cooler object. A cup of water at 20 degrees Celsius in a room at 30 degrees Celsius gains the heat energy and heat up its temperature rise. However, the cup of water at 20 degrees Celsius in a room at 10 degrees Celsius loses the heat energy and cools down. Its temperature will fall. That is what we already know. So the kinetic energy is the energy in motion. The temperature is the average kinetic energy of the molecule. Now the potential energy is the energy in storage. The latent heat or the hidden energy, it is nothing but the latent heat or the hidden energy and cannot be measured with a thermometer. So this potential energy we cannot measure with the help of a thermometer. So phase change, whenever there is a phase change, change in a state is a change in a potential energy. So known as the latent heat because it does not cause a temperature change. So during the phase change, the energy can be absorbed or released, but the energy is hidden because it does not show a change in temperature. And the condensation and freezing releases the energy, evaporation and melting requires the energy. So similarly, the thermal energy, that is the total potential and kinetic energy. Thermal energy is the potential and kinetic energy in an object. It depends on mass, temperature and phase of an object. If both the objects are in the same phase and at the same temperature, which one has more thermal energy? Because more the bigger object will have the more energy, thermal energy.